See, in the above question, it's given that when a particle of mass m moves on a x-axis having potential function as v equal to kx square. If v equal to kx square, then force is minus dv dx, that is minus kx. So that is the usual SHM we know, we are habituated with, and here the corresponding time period is proportional to root over of m by k. So it's actually 2 pi root over m by k if it is a spring force like that. So now here it's slightly different. Here in this problem, you see motion of a particle can be periodic even if the potential energy increases on both sides. So it's a function given, potential energy function. So any potential energy function you have, so you have x here and say any potential energy function. So this is v x, v for potential energy. Now if you look at question number 18, the total energy of the particle is E. It will perform periodic motion only if, say, I denote E by this blue lines rather. So this should be total energy. So you cannot have total energy here. यहाँ पे टोटल एनर्जी नहीं हो सकता, यहाँ पे अगर हुआ तो इट विल नॉट बी ऑसिलेटरी, तो फिर ऑसिलेशन नहीं होगा, रेड लाइन से नहीं होगा, ब्लू लाइन से होगा. दैट मीन कि ये जो है टोटल एनर्जी ई शुड बी लेस देन, दैट मीन्स यहाँ पे देखो इस पॉइंट में this point kinetic energy is equal to 0, and the other point when this blue line intersects the potential energy line, there also kinetic energy is equal to 0, because that's the thing, total energy is equal to E and this curve is that of the potential energy. So when this total energy meets this potential energy curve, that means when ये blue वाला line total energy which is constant and this black curve that is potential energy, when those meet, their kinetic energy is equal to 0. So ये दोनों पॉइंट में, ये पॉइंट और ये पॉइंट में kinetic energy 0 है. So in this range the particle will oscillate to and fro, because at the extreme positions kinetic energy or velocity or the speed is equal to 0 at both extremes. So in question number 18, if you see total energy of the particle is E, it will perform periodic motion. So only if this E is less than V naught. Where is that? E is less than V naught, so option C is correct. So that means E is between 0 to V naught. Now let us look at question number 19. For periodic motion of small amplitude, the time period t of this particle is proportional to this. So it is proportional to, it's for the SHM. For SHM it is proportional to m by k. So we have to work with the dimension analysis method here. We have to follow the method of dimensions, and we see that this k is dimensionally same as alpha times a square. This we can match the dimension. See, so kx, force equal to kx, so it is m t to the power minus 2 k. So this alpha, so what's alpha equal to? So you see alpha x to the power 4. So this potential energy, that means see Vx is equal to alpha x to the power 4. So what is potential energy? Work done ml t to the power minus 2, work done into distance, is equal to alpha into L to the power 4. So alpha is equal to m, so L to the power minus 2 t to the power minus 2. So alpha into a square. So alpha into a square. So a square means you have L square here. So alpha into a square is m t to the power minus 2. So that's why alpha a square is m t to the power minus 2. So from this, in this problem here, see alpha a square. So that means So you see, so that means k dimensionally k and alpha is square similar. So that means is root k is dimensionally equal to alpha. So a root over alpha. So you know, in this question, so option B is correct. So option B is correct. And I've turned to next page for question number 20. You see the acceleration of the particle when x is greater than x naught. So x is greater than x naught. You see this curve where x is greater than x naught, this becomes a flat curve actually. So here, say in this region, x is greater than x naught. So x naught is there where the curve actually uh, uh, changes to a straight line, a flat line. So when this potential energy function is flat, that means this minus dv dx is equal to 0. Minus dv dx equal to 0 implies the force is equal to 0. The force is equal to 0 implies the acceleration is equal to 0. So in this case, this is the correct answer, 0 for the acceleration. So the acceleration of this particle for mod x greater than x naught is, it has to be 0 because the potential energy graph becomes flat, it falls in this region. So acceleration is equal to 0. Thanks.